So as we mentioned in the last video, in the conceptual data model, you start coming up with entities that you are going to be representing. So real world objects, we represent them as entities. We think about the entity relationships, and we said that in some books, you put the attributes in the conceptual model. What are you going to be storing about every entity? Okay. The next thing after the conceptual model comes the logical model. And sometimes they call that the internal model because now you are starting to move forward and start thinking more about implementation details. Now, you're not at the final stage yet where you're going to start creating your tables and your database, but you're in this middle state and it's more closer to what everything is going to look like. So they call it the internal model. And so what is it that we're going to include in this logical data model? What are we going to add? So now we know that we have some entities that we're going to store. We know the relationships between them. If we didn't add the attributes, we're going to add the attributes, and then we're going to start thinking about other things. For example, we're going to think about primary keys. Primary keys is just mean, how am I going to uniquely identify every entity? Everything has to have a unique way of being identified. You as a student at MCC, you're uniquely identified by your banner ID. You as a citizen here in the US have a unique identification, which is your social security number. If you are, like if we have a course, this course is unique by its name and number. You know, a room has a number that is unique. You don't have two rooms in the building that are, 250. If you think about a car has a VIN number. If you think about a computer has a MAC address. So we need to think of a unique way of identifying every object. Now, let's think about furniture. If I'm going to have furniture in a classroom, how am I going to uniquely identify every piece of furniture? It doesn't have a MAC address. It doesn't have a social security number. It doesn't have a VIN number. So maybe I need to come up with my own unique way of how I'm going to identify this entity. And so if there is something that already exists, like a social security number or a VIN number for a car, you can use that. But if there isn't, you need to think, how am I going to uniquely identify each entity, because everything has to be uniquely identified in some way. And so this is one of the things that we start thinking about in the logical data model. Oops. There's one more thing that I want to talk about in this slide, which is the foreign keys. Foreign keys are also used for uniquely identifying items, but they are not stored with the attribute. They are stored with, the entity. So we're going to talk more about foreign keys later, but I just want to say that here what we're seeing is that in the logical model, we are adding more information than we had in the conceptual model. Once you have the logical model, you are closer to implementing things in the database. Now you can move on to the physical data model, and the physical data model is where you add all the details that need to be in place to start creating your tables, like I showed you in that SQL document. So you start thinking, what are the names that I'm going to give to my tables? How many tables do I need to create? So when we start looking more about examples of database design, we're going to see that sometimes you might have a piece of information, an entity, and you're storing that entity information in more than one table for some specific reason. So we need to see how many tables we're going to be creating. What are the column names that I'm going to be choosing for my attributes? Am I going to say F name or first name? Am I going to say BID or banner ID? What are my column names? I need to start thinking about what is the data type that's acceptable for each of these columns. So when I'm talking about my first name, for example, it's going to be a varchar. Varchar means a string, a bunch of characters, but what is the maximum number of characters I'm going to allow to store in there? If I'm talking about salary, how many digits of precision do I need? So we're going to talk about the data types for each of these columns. And then finally, we're going to talk about constraints. What is going to be allowed and what's not going to be allowed. And we're going to talk more about the data types that exist and the different kinds of in future lectures. But for now, the physical data model is kind of the final step where you're actually going to be able to sit down and start creating those tables in your desired database. The physical data model will depend on the database. So if you're doing Oracle or you're doing Postgres or MySQL, you might have different syntax. So at this point, you need to know the database that you need to be you will be working on. And it only comes at the physical data model stage that you need to do that. When you're doing the physical data model, some of the things that you will need to think about, and we're not really going to get into that in this course, but some of the things that the designers have to think about is runtime performance, how fast things are going to run, storage utilization and compression. Are you going to be, is it on a server that's close by, or is the data stored on a machine that's off campus that I need to connect with through the network and the internet might be slow? How am I going to organize my files, access them? Am I going to encrypt the data? So these are things that the physical data model would deal with. But again, we're not going to actually go into them in this course because it's beyond the scope of this course. Also, at the physical data model, when you're doing the design, you need to be aware of the operating system and how it manages files. We will get into this a little bit. I'll show you that in the next videos. But those are some of the things that we'll have to look at. So what I want to do now is look at an example. Let's think about a textbook rental store. So think about our bookstore here at MCC, and they rent out textbooks. So if you go to them and ask them, you know, what do you need from me? So the first thing is that this conceptual data model, we're going to ask the question after we talk to them and get all their views and reports. When we start looking at the conceptual data model, we want to ask, what are the entities that exist? So let's think about a textbook rental store. What entities are there? And you can pause this video, think a little, and then come back and watch the rest. So if you ask them, they'll say, well, we have customers. We have some student customers that come and rent from us. We need to store information about every customer so that we can actually bill them. We need to store information about the textbook, you know, who is the author, the ISBN, the edition, the price, used or not used. And then if you think about relationships, they'll say, well, a customer can rent more than one textbook. So this is called the one-to-many relationship. But again, we're going to talk about that one-to-many relationship in another chapter. But they're going to say, well, a customer can rent a textbook. Okay, now that we know what we're going to be storing and our entities and our relationships, we want to go and move on to the logical data model. So now that we know the entities, we want to know what attributes are we going to be storing about these entities. So if we think about a customer, we probably want to know their name. We want to know a unique way of identifying this customer. So we'll use the banner ID since they are students. We want to know their address, their phone number, their email, and their credit card information. If we think about a textbook, we want to store the title, the publisher, the condition, the price, the rental date, the return date, and the ISBN. And if we look at all these attributes, the ISBN is the primary key, can be used as the primary key because the ISBN can uniquely identify a textbook. Once we are ready, we can move on to the physical data model and say, okay, if I'm going to store information in the database, what tables do I need to create? Well, I need to create a table to store the customer information and a table for the textbook information. So I'm going to create a table called customer and a table called textbook. And here, when I'm starting to store the information, I'm going to store these columns, first name, last name, banner ID, street name. And here you see that I've decided to break down the address into different parts. Street name, house number, apartment number, city, state, zip code. When I started storing information about the credit card attribute, I said I need the name, a number as two different fields, the expiration date and the security code. So you see that this is slightly different. It's adding more information than the logical data model. I'm not just storing credit card as one big blob or one big text in the logic in the database. I actually had to break it down. And similarly, when we talk about a textbook, what are the columns that I'm going to be storing in there? And so what I want you to do for the classwork today is think about an airline company. Think about American Airlines or any airline company. Imagine that you're talking to them and they told you these are our business rules. We want customers to be able to search for available flights. We want customers to be able to see their reservations. And we want managers to be able to assign pilots and flight attendants to each flight. So I want you to think about what are the entities that exist and what are the relationships between them. And that will be the conceptual data model. And then what are the attributes that you need to store about each entity and how are you going to uniquely identify each entity? That's the primary key. And then if you were to create tables in a database, what are the table names? What are the column names? And do you make sure that here, whatever attributes, is every attribute going to be stored as a column, or is there an attribute that I need to break up into more than one column? So what you're going to do is you're going to type this up in a Word document, and then you're just going to attach this Word document to Blackboard and submit it with the classwork.